star is the inverse norm 1 point whatever divided by 2. So it's like working from the bottom up almost. If you know that it's 0.8 comma 9, can you like put it back into this? What did I start with? I'm not gonna say yet. But what did I like? It was what plus or minus what that would end up in 0.8 comma 0.9. Does that make sense? What I'm asking.
Yeah.
So there's an assignment that the school did. You want to start it?
Is the pond in Cal? Is that due to that?
No. It's not due to the gateway, but obviously that'll get pushed back because of the snow days. So I'll talk about it. Remind me.
Okay. Because I was like
You
thinking
didn't
about it.
learn.
I was thinking about it Thursday. I was like, wait.
Yeah. So you get the. I guess I could say state though.
So if you go into the practice and Google test folder, I made a new folder that says SAT 2018 April school or whatever. And then I trimmed the PDF so it doesn't have the English crap on it. And then it's got, and then there's a separate one that says conversion users. So then we just gotta make a Google form and
It's for the corrections.
then do the hints.
Okay.
I'll try to get on a video.
So that's what it means. And then when it asks for like point estimate, it means like.
Oh, the point estimate's the p hat. Yeah.
Yeah. It's not p. Well, yeah, it is.
P?
It's p hat plus or minus margin.
I think
Okay.
you're right, but I'm
let me start talking through them. So, again, this is the inverse norm 1.8 divided by 2, inverse norm 1.9 divided by 2, inverse norm 1.95 divided by 2. And so what happens to Z star, so as the confidence level gets bigger, what happens to Z star? It also gets bigger, right? And so that means that this number is getting bigger. And if this number gets bigger, since it's being multiplied by this, what happens to your margin of error? If that number gets bigger, doesn't the whole margin of error get bigger? So then you're adding and subtracting a bigger number, and your interval gets wider and wider. So are we more likely to capture the true answer, or less likely to capture the true answer? More likely. Remember, if I want to be 100% confident that I'm capturing the true answer, what's my interval going to be? 0 to 1. Like, I'm not even going to bother. Like, if I have to be right, if I have to capture it, I'm going to go 0 to 1. So suppose our confidence interval is 0.8, 0.9. So to unpack that, I don't know how to best explain this. I think the example might help the most. So that's really the same as 0.85 and then 0.05 in each direction. So what is the point estimate is 0.85. What is the margin of error is 0.05. Rewrite it is 0.85 plus or minus 0.05. And then the width is 0.10. So the width is just how far apart it is. The margin of error, how do you get to the margin of error from the width? Divided by 2. And then you can kind of go backwards from there. So let me throw another one up here. Let's say it's 0.4 to 0.6. Answer those exact same questions with 0.4 to 0.6. So it's not out anymore. 0.4 to 0.6. So you want to start with the width. When you cut the width in half, that gives you the margin of error. And then you can kind of work from there to get your point estimate. So that's your end result. What's in the middle? How much did I add or subtract from 0.5 to get to the point? So that's the setup, and then this is your point estimate. And this is your margin of error. Yeah, I didn't explain it very clearly. Yeah. Thanks, Meads. So I think I could have done a better job explaining that. If you think about like a number line, so if 0.4 is here, 0.6 is here, you started in the middle and you went a certain amount each way. So what's in the middle of 0.4 and 0.6 is 0.5, and if you're at 0.5, how much did you go each way? 0.1. So that's your like rewrite, so 0.5 plus or minus 0.1. And then this first number is your point estimate, that's like our best guess. And this is the margin of error, that's how much you go each way. So the point estimate's 0.5, your margin of error is 0.1. And then the width is just how big is it. And then how is the width always going to be related to the margin of error? It's just going to be double, right? Or half, depending on which way you look at it. Does that help for number 2? And then number 3, if I increase my sample size and hold everything else the same, what happens to the margin of error? Well, the sample size is on the bottom of the fraction. So when I divide by a bigger number, what happens to this overall value? It gets smaller. So that'll make my margin of error smaller, which would make the width of my interval smaller. It's like I'm more confident in my work, so I can narrow down my estimate. Questions on any of that then? Alright, if you go to Schoology, there's an assignment on there, so like links you to this website, which has a pretty good like activity. Kind of runs you through. I want you to answer the questions to the activity in the comments on Schoology. And that's an assignment. That's like a required assignment. So if you come to me after this next test and ask for recovery, I'm gonna make sure you did that. That's one of the required assignments. Yeah. Con will. I haven't assigned any con yet, but if and when I do, that would be also. Yeah, John. Just like sit by it. What do you mean? Oh, you're own.
So, freshman software, different Google charges.
Oh, really?
That's like Apple changing their charges like half a million or whatever.
So everyone wants to buy new stuff.
That's what they do.